Good day. My name is Dave Glover. Today, we're going to talk about the RSA Netwitness platform. The RSA Netwitness platform is a purpose-built platform to allow the analyst to find, detect, and remediate cyber risks quickly. We do this by providing a full visibility into what's going on your network. This is enabled by collecting logs, packets, endpoint, and netflow. Let's talk and draw about the pieces that are required to enable this platform to function fully. If we start with the logs module, the first thing we need to do is to be able to collect the logs. And we do that by a capture device that we call a log decoder. The log decoder's functions are pretty simple. First and foremost, we need to capture the log data. We do this by many different protocols, whether syslog or Windows Remote Management or some of the other protocols that are required to capture these devices. Once we capture this data, the next thing we need to do is to parse all the information. Using the over 300 log parsers within the platform, we can bring value to the data that's being captured. If you have devices that we do not support, you do have the capability to write as many custom parsers as required to drive what you're looking for. Once we've captured, we've parsed, the next main function of the decoder is to enrich this information. Now, the enrichment can happen many different ways. You can bring threat feeds into the platform using some external data source. You could include or upload your own threat feeds into the platform. In addition to threat feeds, you can also upload business intelligence feeds, such as this user belongs to a database admin group, or these are my PCI devices, anything along those lines. The next thing on top of a log decoder is a concentrator. The concentrator's main job is to index data for fast retrieval. Data is captured, parsed, enriched at a decoder level, brought to the concentrator for indexing. This is what allows you to scan through multi-terabytes worth of data, or even petabytes worth of data, in a very rapid manner. The next set of modules for input would be on my packet side. Much like in the log modules with our log decoder, we have the same type of technology to capture network traffic. The vernacular here is a packet decoder. The packet decoder has all of the same functions as a log decoder. It will capture all of the network traffic coming in. It will then parse all that information and enrich it the same way that a log decoder does. Also, the same functions apply for a concentrator. Its job is to gather the data from the packet decoder and index it for high-speed retrieval. If we move on to endpoint, we have what's called an endpoint log hybrid. Now, the endpoint log hybrid has a combination of a decoder and a concentrator within it. In order to capture the endpoint type data, for example, what's running in memory or what's on disk or file footprints, we need an agent to be installed. We provide 3 different variants of the agent. There is a Linux variant, a Windows, and a Mac agent. By using those 3 different agents, bringing the data in, we can then have full visibility on what's happening on the endpoint. One of the last components that we talked about was netflow. Netflow has a unique advantage of being captured directly by a log decoder. there is no additional architecture required to collect netflow. So that will flow directly into a log decoder. Once I have all of this data coming into the system, being indexed for fast retrieval, I need to be able to actually take a look at it. The way I do that is by using my hedge unit system. The hedge unit allows me to look into any one of these data points, or a combination of them. Using a broker, the broker allows me to view into all of this data at the same time. I can very easily investigate an IP address, for example, and I would see it across my network, across my logs, and across my endpoint. So it provides me that full visibility into what's being generated on your network. This is great for collecting and analyzing. I also want to be able to do some alerting as well. And that alerting may be done on just logs. So if we have a compliance use case where we need to take a look at or alert on users accessing high privilege shares, for example, or touching files, or creating user accounts, I would want to correlate the data against my log decoders or across the logs that are coming in. Much the same way, if I want to take a look at users that are FTPing data out that contains certain files in it, I could correlate across just the packets. The powerfulness of the NetWitness suite is to be able to bring that all together and not only cross-device correlate, but cross-medium correlate. In other words, I could create a correlation rule that looks at the log data, specific elements, followed by something in the packet side or the network segments, followed by something running in memory on the host. So if we reverse that just a little bit, I have a correlation rule that I have built, or using one of the many hundreds that are included out of the box, that look for users downloading a file, followed by something running in memory on any one of the agent or one of the hosts that you have in your network, followed by communications across the firewalls. I can build those correlation rules, or like I said, there's many of those that are included right out of the box. So how do we enable that correlation? Using the event stream analysis box, which is our correlation engine, it takes data feeds from all of these different components to bring all this information to a central location to be able to be run against our correlation engines. Now, the ESA is fantastic. I can build as many correlation rules as I want, but the challenge there is that I have to define what the bad behavior is. I have to know what I want to, as an outcome, to be able to build those rules. If we introduce one other component into the infrastructure, the UEBA component, or User Entity Behavioral Analytics component, is a ruleless, stateless engine that looks for anomalies within the data that's coming in. Primarily, UEBA is built on two different data models, one looking at user behavior, which is where the U comes from, and entity, or E, is using processes from the endpoint. Now, this is very different than what a lot of other vendors have in there. So if we look at the other vendors, they all built their UEBA systems using just user data. The RSA UEBA platform, because of our capture and collection of the endpoint data, is able to bring that into the UEBA system to provide all those anomaly detection without any intervention by the end user or by the analyst. There is nothing that I need to configure or tweak or build on the UEBA system. It takes a look at data over long periods of time to understand what normal behaviors are, and then it starts looking for deviations from those. That is very different than the correlation engine, correlation rules that you may build on the ESA system. Everything that we see here from the concentrators to ESA to UEBA to the brokers are all managed by the hedge unit. I do not go into my UEBA system and take a look at the data there on a separate UI than I do from the ESA. Everything is accessible from the hedge unit. So the minute that I log into the hedge unit, I can perform many different functions. I can analyze the data as we talked about. I can go ahead and build correlation rules. I can take a look at what the UEBA system has done. Now, in addition to working with the data and understanding and finding threats that I have, one of the other core functions of the hedge unit is to provide the administration functions for your system. Now, we've drawn a very small architecture here. We could scale this out horizontally and vertically to provide for massive global deployment. But the key is the hedge unit provides that administration function so that if I need to upgrade from version to version, instead of being required to log into every different component to do it locally, I log into the hedge unit, I pick my version, and I say deploy, and through that centralized unit or centralized UI, it pushes out those updates through the entire platform, which makes administration very, very simple. In addition to administration, or in addition to the administration for upgrades and so forth, it's where I define all my user access, my role-based access within the platform. Maybe I have a user that logs in and they're only allowed to see the endpoint data, or maybe they're only allowed to see the network traffic or the log traffic or some subset of those. All of that is defined through the hedge unit through the role-based access. So this allows for a low management, highly scalable solution that provides full visibility into all of the traffic on your network. So in summary, we have a very modular, flexible architecture. It allows for on-prem, virtual, or cloud, or a hybrid thereof. It meets the challenges and the needs of not only the administrator from being able to log in and perform your administration functions, such as upgrades, user account creations, role-based access, but from an analyst perspective as well. I can log into the hedge unit and through my brokers analyze all of the data from my logs, from my packet, from my endpoint, be able to take a look at what's going on from a correlation perspective, both from rules that I have written or enabled that I downloaded from the system, or through my user entity behavioral analytics. This allows, again, for mitigating cyber risk by finding, detecting, and responding quickly within the platform. Thank you.